exactly these lenses are for, what exactly these lenses helps us. So basically, these lenses helps us to focus on displays that are really close to our eyes, basically. So what happens when we keep our HMDs? We keep our phone or a HMD very close to our eye. So if it's something which is close to our eye, we can't see it. So these lenses will help us to focus on that particular area or particular display. So they magnify the image so that we can see everything in a normal way.
Excuse me, sir. Sir, you are sharing something, sir?
No, I have not shared anything.
Okay,
You
okay,
want
sir.
me to share the same slides? Already I shared you the other day.
Okay, sir.
You want me, like, I can share this?
No, sir. No, you can continue, sir.
Okay then. Okay, yeah. So basically, these optics will help us to magnify the image, image of a particular image in the virtual environment, basically. So the next one is a display. So if you look at the display, every HMD have a display. So especially in a higher end gadget, higher end HMDs, you have a LED displays inside built in. And if you take this lower end, like Samsung Gear V or Google Cardboard, your phone itself is a display basically here. So these are like these displays what helps us to display that image what we are gonna see. Like Rift, Go, Vibe have all these have embedded display panels. Like inside there are already display panels, so we don't need to depend on the phone or any other external things. Cardboard and all, obviously I told you, phone itself works as a display panel. So why do we need to have a high resolution in this display panels? What's the purpose of that? So basically, if we look at the normal eye resolution, the resolution of an eye which captures a particular image, that is like 16,000 by 16,000 pixels. But in the reality, in today's technical world, we only hardly have a 4K resolution. So most of our headsets are at least full HD display panels with the
if you don't mind, some of the participants are asking to share the PPT.
Sure, I can share that.
It's better if you switch on the camera also, if it is okay for you. Otherwise, it will be okay if you share the PPT.
Sure, I'll share it. Yeah, just a moment. Can you see my screen now?
Yes.
Yeah.
Yes, sir. Your screen is visible. You can go ahead.
Yeah, now. So stop me if you are like if you have anything to ask me. Okay. I'm just quickly recapping all the stuff which I was speaking the other day. So this is what I'm talking about. These are the HMDs. These are, we call this as a mobile HMDs, basically a mobile VR HMDs, and these are HMDs of desktop versions. So basically, inbuilt in these HMDs, you have a display panels now. Each display panels depends here. It depends on your mobile headset. Here it will be around 1080 by 1200 pixels of the display resolution. So one more important thing here we need to consider is the motion blur, especially in the displays. So this technology will help us what motion blur is about, or low persistence we call it. So instead of showing a full frame, so this whenever you're trying to run an image or any environment, so we show it by frames per second. So in VR, the minimum frames which we need to consider is 60 frames per second, as I said earlier. So how do we get this frame rate like much higher? So in this technology, what we do is we don't show the image which is not necessary for the user. Basically, we hide those LEDs basically. So if user is trying to see in a particular direction, in the other direction, so the rest of the other degrees and all, it's completely blurred. There is no image, which is all the LEDs are like off basically, or the what I can say is like it's switched off. Only the portion which we are trying to concentrate only is displayed or focused. So whenever you turn your head or your move, so only that part is enabled and the other part is disabled basically. So that this is how we make sure our frame rate always be higher, and we achieve this low persistence or motion blur or these kind of challenges we conquer like this. Basically, this is the technology where these VR headsets will help us out in this. So I want to show another one. So one more challenge, one more, I won't say challenge, but one more thing I want to consider, especially in this field, is the tracking one. So there is no particular universal system in this field of tracking of the device, but different companies use different technologies for tracking their HMDs basically. So if you look at HTC Vive, this headset, so they use laser. These are laser. These small boxes are laser boxes. These boxes, what they do is they emit they send the lasers. They send the lasers. So once the laser fall on the HMD, it gives you the where exactly the HMD is in the space. So generally HMDs are we put these HMDs to our head. So whenever we try to move the head up and down or left or different directions, so these lasers keeps on shooting the rays. So these rays gives the input where exactly this HMD is located in this space. That's how we are able to track this HMDs, and we are trying to calculate and we are trying to show or do some application or show that graphical environment basically. So this is how we do it. And there is one more is the Oculus Rift. They use the cameras basically. So what they do is like I should have this image also. Yeah, this one. Yeah, basically this is the headset. So basically this is Oculus Rift, we call it. So this is like the cameras basically. These cameras tracking all this. There are so many inbuilt. There are so many LED lights basically. If I have, I'll just quickly Google it and I'll try to show you. Oculus Rift LED. So this is how it looks inside, basically. If you look at this, this is the device. So these are different LEDs positioned on the headset. So whenever the headset tries to move, each LED have a particular location. So based on whenever they try to move, the camera captures that position of that LEDs. Based on that, it will calculate, and we are generating this. We are able to track this model wherever this HMD is in this particular space. This is in this technology. So the other in the HMD in the this one in the Y we are using the laser ones. So in some other products we use magnetic field also, but these are all in the research place. Mostly there is no like particular universe where exactly you have a perfect a tracking device. This is a particular tracking device which helps in the VR. So there's no such thing right now in the industry. But most of the industry they use either of these two. It can be a Rift S or Quest. There are like, after this Rift, there is a Rift S and Quest, and one more is the HTC Vive they use. So this is a mobile-based HMDs basically. So your mobile itself acts as a HMD basically. So it depends upon your mobile resolution, the display will be. And here we call this mobile HMDs, we call as 3 degrees of freedom, that is 3 DOF, we call it. So only hardly you can rotate, or you can rotate, you can see from left to right or up and down. Hardly you can do that. You can't track the device basically. In this, you can't track it. In the earlier one, we call this as a desktop version or full VR we call. So here you can track the device. You can, whenever you're tracking, you can move this in the environment, in the virtual environment. But here you can't. But this we call this as HTC Vive. We call this as 6 DOF. We call this as 6 degrees of freedom, basically. So you can move, rotate, left to right, top to bottom. You can move forward, backward, all this stuff you can do as what we are doing in normal life. So these mobile ones are a little cheaper, and the desktop ones are a bit costlier. So this is what cardboard I'm talking about like the other day. So if anyone wants to consider to buy a headset, so start with your cardboard. This is how the cardboard looks like. So make sure you have, whenever you try to buy, there is this trigger button here, this button, so that when you want to interact with your user interface, this is very easy to interact other than only case. Okay. So this is how your whenever you have this, we call this as a this is image for one eye and this is image for another eye. We call this a stereoscopic image, and this is your this is how you put your mobile. So whenever you want to interact or touch the screen, so when you press this button here, there is a small kind of a cushion, kind of a cardboard, so which touches the screen. When it touches the screen, the action will happen basically. So I'll try to show you tomorrow. I'll try to bring this real cardboard with me, and the HMD if possible also. I'll try to show the difference also inside that. So this is also same thing like a Samsung Gear VR. This is from Sony. These are all different headsets which are available. So these are different HMDs available in the market. So these are the 3 things which we need to consider. One is optics, that's a lens. Another one is display. Another one is the tracking. Based on your requirement, you can go for tracking or you don't need to go for tracking. So So please put me like if you have any questions also. So what? So one more important topic in this VR is motion sickness. We call this as motion sickness. So this is a challenge to every biggest challenge in the VR industry. So how we overcome by these challenges are we are making sure when we are trying to build the environment, it should be that smooth, as smooth as possible, and it should be as low graphic rendering as possible. Basically, when you're trying to render the graphics, if the mesh is not that heavy, then it renders very soon, so that you don't feel exactly the slow or the dizzy or the headache stuff, all the stuff. So don't go for a high-end mesh which takes some time to load on your phone or on your device. That will make the person who are trying to use your application or trying to play your game, they don't feel like doing it. So before so the next topic is we need to, how do we develop these applications basically? So there are different ways to develop this application. So if
excuse me, sir.
yeah,
Sir, which HMD we should use, sir?
so that's what I suggested the other day is based on your requirement. This is there's no particular thing you should use this or that. So if you're trying to use a high-end application, if you're trying to develop a high-end application or high-end graphics, there is rich content of a graphics, then you should go for the desktop version of that, because your mobile can't process that much, because there is no separate GPU inside your mobile. So better to go.
These are desktop versions, sir. Samsung Gear.
No. These are the mobile versions. These are the desktop versions. This HTC Vive and these two are the desktop versions, basically.
Oculus is also desktop version.
Exactly.
Okay, sir. So, sir, it is expensive, sir.
Yeah, these are expensive. This costs you around from 30,000 to 80,000.
Okay.
Wide range. Yeah.
Yes, sir. Thank you, sir.
It's all depends on your. And one more thing is, if you're trying to use this Oculus Rift or HTC Vive, then it should have a supported laptop also, or a desktop, or the graphic card. Basically, I want to say it's the graphic card.
Graphic card means, sir, NVIDIA graphics card you're asking.
Exactly.
You're saying.
Yeah, exactly.
So, sir, how much 2 GB is sufficient, sir?
No. Minimum should be it should be more than 4 GB. So
NVIDIA graphics card 4 GB, sir.
Yeah, more than 4 GB. There should be plus 4 GB. So the Oculus, basically the Oculus, I'll try to share a page, the resources also. So how much graphic card required for the Rift and HTC Vive. So just quickly, like when you say Oculus Rift hardware requirement, it will give you, these are the minimum requirement for the recommended specs. This will give you that. Here you have how much, should be the processor, what will be the graphic card processor, all this stuff. But what I personally suggest is make sure at least you should have a 1080 graphic card, and better to use 8 GB plus. Earlier, 8 GB or more than 8 GB plus. That's much better always. So if you couldn't afford, then try to have this 1050 Ti or 1050, at least 6 GB or something like that. That also should work, but always better recommended to go plus 8 GB. These are like expensive laptops. Basically, you can say these are not normal, like these are like high-end gaming laptops basically. So I'll try to share this link also. So yeah. So you have any other questions before going to another topic? Okay. So how do we develop these kind of applications basically? There are two ways. Either you can go for a native, like it can be an Android Studio or Xcode for iOS, or so for Windows you can use Unity also. Unity will help you. Basically, I want to tell you more about Unity also. So you can, it's up to you. But what the advantages with the Unity? Why industry uses Unity? That I want to say. So Unity is basically a game engine. Generally, it started for the development of the games. So in games, mostly what we do is generally, if you take all the games are generally played. The player starts moving here and there, running, jumping, walking. All these characters, which a character generally does all this in almost all the games. So, and in most of the games, what they have a close to the physical world. So what exactly? So, if a player jumps, he should come down, or he can shoot a bullet, or the bullet should keep on flowing whenever there is applied some force is applied to the bullet. Or if we throw some ball, it should go with some speed and it should fall down. So all these are there with the game engine already. All these features are there in the games basically. The same features, most of the stuff in the VR applications also we use. So we use, suppose if we take a mechanical automobile industry. If you want to train a mechanic, so we need to pick a spanner or some tools. Okay, this is a tool which we'll say, hey, this is the tool which we try to remove this bolt or that screw, that nuts, or all this stuff we say. So how do we use it? So once you catch it, once you remove the hand, what will happen? It should fall down. It should fall down. So this happens the same thing here also in the VR also. So same kind of a features and same thing like in games also, same thing as in games also, in VR also it should happen the same thing. So that's why we use the Unity game engine, because all these features are already inbuilt, so we don't need to reinvent the wheel. So we can use these features and we can develop the commercial products, commercial applications basically. That's what we are using the Unity game engine. There are other game engines also. It's not like there's only one particular game engine we need to use it. There's an Unreal engine, other engines. So even Unreal is also another game engine basically. So, but 90% of the industry, mostly they use Unity for their products, is because of a very good documentation, especially, and very good support. And this is based on a .NET platform that is from the Microsoft. So the C# which is based on .NET platform. So a wide support, a wide developers, and a wide range of platforms it supports basically. So even though we don't know how to develop an application for Android or iOS, Unity helps us in this. So all we need to learn, all we need to do is we need to learn about the C# scripting, how to code what kind of plugins we want to use it. That's all we need to know. So most of the features in the VR already, the plugins are available. Only thing is we need to know what plugin, when to use this plugin, and where the code, where the application starts and where the code is going. That's all we need to track it, and we use some logic according to our need and try to build our application. So that's all we need to do. So that's why we use this Unity game engine, as it supports wide variety of platforms. The same code write once, deploy to any platform you need. Hands-on session on VR. See, practically, as we are all different location, and I guess most of you didn't have the hardware, so I'm not sure the practically it's possible, but I can promise you one thing. I'll try to show with at least the cardboard one, so that the development process, you can understand how this things works and all. That I can promise, at least the cardboard one. Okay. Any other questions? Okay, let's go to Unity. So I hope everyone installed your Unity, and you should be able to see like the screen which like this, the Unity hub, and here the projects should be there. So for me there are so many projects here in my name, but maybe for you it's none. So first thing what we need to do is we need to create a new project by clicking a new. So here, for the time being, you only have one version of the Unity, as you installed only one version. If you have a multiple version, you see like this. So which version you want to select, it's up to you. You can select any version. By default, if it's one version, then only one new button will be there. So coming back to this thing, templates. So as I said, the Unity is a game engine. So it has wide variety of different components basically. So if you want to develop an application for only a mobile-based application, not a VR one, then you can use this 2D platform, 2D template. But if you want to develop an application like simulation kind of games or any kind of this thing for VR or AR, then we use this 3D applications basically. Suppose you have a very rich content of a graphics where your visualization is like too high. Generally, we use this high definition one. So only consider whether you want to have a 2D kind of application. If it's not VR, then it's 2D. If it's a VR or AR or any other simulation kind of a games, then it's a 3D basically. Any application for mobile or laptop or desktop, you can use this 2D also. So as we are into the we are developing a VR application, so we need to take this template basically, template of 3D. So try to give a project name. So try to give a meaningful name so that tomorrow you come here and by looking the name of the project name, you should be able to know what exactly the project is about. So
Sir, one
yeah,
doubt,
go
sir.
ahead.
So, what is the different rendering pipeline, sir, and what is that uses, sir?
Which one?
HD rendering,
High definition.
HDRP. Yes, sir.
So these are for high-end graphics oriented gaming stuff and cinematic ones. So if you want to create a, with this Unity game engine, not only you can develop games, but you can use for filmmaking also. So that is for that. So we don't need to, we won't be concentrating on any of these, but we concentrate mostly on 2D or a 3D. But generally Unity game engine is also for that, also for filmmaking and film editing and animation kind of a stuff. Not animation, but filmmaking basically.
Okay, 1 minute.
Yeah.
Okay, sir. Thank
Yeah. So so let's dive into the Unity game engine and what we have here. So this is what Unity interface looks like. This is a default layout, we call it. This is a default layout. So this layout is like you can just drag it and drop it according to your needs. Suppose you don't like this layout, you can just drag it like this. These are like mobile. You want to keep it here, it's all up to you. You can just drag it and drop it wherever you want to, like this. So it's all up to you how you want to put it. So if you feel like this is the layout which I like it, then you just come here, you save your layout like this and say save it better. So next time whenever you come here, default will be there and we just saved our layout. That's also available. So it's all, these are like flexible layouts. It's up to you. So the next thing is, as I said, Unity supports a different wide range of platforms. This is where you can see all the different platforms available for this build. And here in build also you have all these preferences for for building the Android applications. So directly it will give try to build the application, it directly gives you the APK file of that. So I'll just come. So let's start with the Unity interface. Basically, this is how the Unity interface will be there. So we call this topmost this place here, top panel or navigation panel, we call it. This place. So in the topmost, you have the first one is the left, the hand symbol. We call this as hand tool. The next one is a move tool. Next one is a rotate tool. So I'll come from the first one. So first, this is a top panel or a navigation panel, we call it. And the other one is a hierarchy panel, this side, the left corner. On the top, it's written, you can see there's a hierarchy window, or you can take a window or a panel, it's up to you. So this is a hierarchy window. We call this place as a scene or game window. You can see there's a scene and this is a game window. If you click, this is where the output you can see, and this is where you develop, you build the application, basically design the application. Just a moment. So this is where, sorry. So this is where you design the application, and this is where you see the output of the application. This is basically asset store. We collect different assets required for the, it can be a graphical, it can be a plugins, it can be anything. This is basically a store of the Unity. If you want to publish any game, or if you want to get assets to your store, this is where you get it. Some are paid, some are free. So all these things, you can say click top free. You can get all these assets are free for your application, where you can use in your applications. So this is a scene or a game window, and the next one is an inspector window. This place is an inspector window. We call it as an inspector window. And this place, we call this as a project or console window in the last one, basically. So totally, how many windows we have? We have 5 windows, basically. We can call this as a top window, this top one, and the next one is a hierarchy window, the left one, and a scene or a game window, or next one is the inspector window, this place, and then this place is a project window. So let's start from the top one. So quickly, what I add is a cube. So if you look at this symbol, this is a hand tool. So this helps to move the scene like this. Either you can zoom in or zoom out. Zoom in, zoom out, like with your, try to use your mouse, because it's very hard using the touchpad. So, and one more trick I want to tell you about is here, press Alt button and press the left click mouse button and try to move your mouse. Press Alt plus left click mouse and try to move your mouse. You can see all on all 360 directions, basically. So like this. So once again, I'll try to say is the left click. So Alt plus left click mouse and try to move your mouse by pressing these 2. So can you do this like this? So this is very important whenever you're trying to design the game. If you want to see the different directions, then you zoom in, zoom out. This is where you use this tool. So one thing you need to see, the position of my cube is 0, 0, 0. So that's what it says means the position of my cube in this space is at 0, 0, 0, 0 location.
Sir, how we can zoom in and zoom out this cube?
Scroll, mouse. Use your mouse. Okay. Scroll button. Are you using a touchpad or mouse? If you are using your touchpad, it should be 2 fingers.
Yeah, sir,
large and
yes.
You got it?
Yeah, got it.
Yeah. If it's your mouse, then your middle scroll button. You can zoom in and zoom out. So if you press Alt and left click mouse button and try to rotate your mouse, you can have this. Like this. So
Excuse me, sir.
yeah.
Sir, how did you take that cube from?
Yeah, I'll tell you that. So see, either there's a plus symbol. Can you see this plus symbol here?
Yeah.
So click on this plus symbol, 3D object cube, or next one game object. Here in the top you have this game object, 3D object cube, or right click in your hierarchy, 3D object cube.
Okay, sir. Got it. Thank you, sir.
Yeah. So this is basically to move the scene, not to move the object. I'll tell you the difference between a scene and object. Scene holds multiple objects. In a scene, there can be any number of objects. So we call all these as an object or game object. You can call any name basically. Main camera, cube. These are all different objects. This is a scene. The name of this scene is sample scene. You can have your own name. It's up to you. So when we are into the next session, I'll tell you how to create a scenes and how to add the objects to the scene also. But for the time being, just remember, this is a just a scene name. We call this because this is a scene. We are trying to develop an environment or a scene, design a scene. So that's why we have the scene name. So next one is a main camera, direction light, and cube. Just give me just 1 second. I'll just pick this column up. Yeah, sorry for that. So this is how we move the scene. Scene holds multiple objects. So the next one is a move tool. You can see this plus symbol. So this is a move tool. So if you press this, suddenly you can see there is a arrows, left arrow, like this kind of arrows you can see on top like this. So you have, you can see the arrows. So here the red arrow is the left arrow, basically left to right arrow. So if you want to move from in the x-axis from positive to negative or negative to positive, this is where. So this is a top arrow. We call this as a y-axis, top to bottom. So this is the one, the green one. The z is to move forward and backward. That is on the z-axis, this one. So now I want to tell you, I'll just quickly switch on this thing. I'll stop presenting and I'll show you the finger, how you need to consider this thing. So try to take your left hand and I'm gonna show the same thing with my hand basically. So what you need to do is, so put your left hand, take your left hand like this. Okay, so now this is how it looks for any object, any game object or any object in the space have all these x, y, and z coordinates. This is for the x-axis. That means a left to right. So if you suppose my object is in the at 0, 0 position, this is the center of the position. Take this as an example. This is exactly center of the position. The cube, this is a cube, and this is at the center of the position like this. If I want to move towards left, then in this axis, I need to move my cube like this. That is, in this axis, this is the x-axis. Suppose I want to move it towards the right, this is what I need to move like this. If I want to move from the top to bottom, then I need to use this y-axis. This is how it should go. Top to bottom, this one. If I want to move forward and backward, this is the finger. So this is like a z-axis. So this is how you move it. You move forward, you move backward. This is how it works. So left to right is the x-axis, like this. Top to bottom, forward and backward. Am I clear, or should I make it, or should I repeat once again?
Clear, sir.
Yeah. Only the axis. Don't worry anything about the pattern right now. No need to worry anything about it. Only the x-axis, because this is only tells the position of your particular object. So where exactly your object is. If your object is trying to move from the left to right, then you should think, okay, in this finger, this thumb finger is moving like this here and there. If it's moving up and down, that means you need to consider this positions for moving this object in top to bottom and forward to backward. Okay. So this is what it is. So now if you look at this, my cube, so if you want to move your cube on x-axis, so hold your cube
Excuse
on
me,
edge
sir.
of the, yeah.
This direction is how we can get these directions on cube, sir. We are not getting these directions on cube, sir. This direction symbol that is at the
So
corner.
yeah, so just a moment. So what you need to do is select the cube first like this and press this button, the move tool.
Okay.
You'll get this.
Okay. Yeah,
Yeah.
thank you.
Yeah. So suppose now I want to move my cube on towards the left and right. So now where exactly you need to move? So this arrow symbol, hold on the arrow symbol, not in the center or not in the middle or anywhere. Don't touch this at all in the centers. Okay, only on the edge of the arrow, say like this. This is the player. You hold it and try to move your cube like this. See this. Now, whenever you try to move, you can see my position here. It's only the x-axis which is going to change. It's not y or not z or any other things. So when I try to move, I should move only in the left. It's a positive. The negative is towards the left. See this. Right, left, right, left. You can see the positions. So either you can change the position of your cube like this, or you can directly put the values also like this. So suppose I want to have, suppose I want to put it, the values directly, I can put it like this also. If I want to put like -10, I can put it -10. So directly you can put the values, or if you want to change based on where exactly, that also you can do it. It's up to you. You hold the arrow and try to move left and right, you can do it, or you can directly put. Or here, the next to this X, if you bring your cursor, you can see the scrolling one. See this, like this also you can do. Press your left click mouse button and drag. You can drag like this. These are the three ways where you can implement to move your particular any game object. Basically, this is how we do it for any game object. Doesn't matter. This is how you move the position. The same thing with the Y also. Same thing, up, and down and Z. So you may have a question, why not in the center, from the center? So I'll tell you. So if you look at these two in the center, if I try to hold like this, see my values of my Y and Z also will move actually. So can you see this? Both my X and Z values are changed. So it's only in the particular direction. Make sure only in the particular direction you move your object, from left to right or right to left, top to bottom, forward to backward. Try to experiment yourself. Suppose you want to see this cube from the top angle, then you have here. So if you click on this Y, you can see from the top. Suppose you want to see from the left or right direction, then it's from here. If you want to see from the same thing backward or forward direction, this is from like this. Like this. This is a perspective view, this is a top view, this is a left view, this is back view. So basically this is for like a designing purpose. So whenever you want to design something, some structure or the size, shape of a particular object, then we use these things. Okay. So suppose you want to quickly change the positions. Either you go here, click on reset. Reset means it will come back to 0000 position, respect to whatever the data is here. Except to the scale value, the rest everything will be 000. Suppose if you couldn't find the cube, double click on the cube like this, you'll get your cube back. Am I clear, or like do you want me slow a bit and do it again and again?
It's okay, sir.
It's okay? Okay. So the next thing is, this is how you move a particular object. So if it's a main camera, or it's the same thing. See, if it's a main camera, it's also same thing. This is how you move it. If it's a light also, it's the same thing. This is how you move it. So it doesn't matter. Any object, if you want to move, you need to click on this move tool, select the game object, select the object, and select the move tool, and try to move the object. That's it. So the next one is the rotate tool. If you see, the next to the move tool, there is a rotate tool here. So click on this rotate tool. So you want to rotate your particular object on a particular direction. Same thing. If you want to rotate on the x-axis, then this is the one. Same red, green for top to bottom, and Z for on the z-axis. Sometimes you can see three values keeps on changing when you are trying to rotate. We call this as a gimbal lock. I'll try to explain when we are trying to in the scripting. In the scripting, I'll try to explain why this happens, why Unity, how does Unity work on the rotation side. So there is a different approach for the rotations. So see this, all the three values, even though I'm moving on the y-axis only, but you can see all the three values are changing. See this. If you want to, same thing here also. See, either you can use here, or if you want to change the rotation like this, you can do it like this. Or it's the same thing with y here, drag it like this. Or you directly can put the values also, it's up to you. Like this. So I hope this rotate tool is clear. Basically, if you want to rotate an object on a particular axis, then we use this tool. So the next to the scale button, next to the rotate tool, there is a scale tool. Scale tool is to make your object, to make it bigger or smaller on that particular direction. So suppose I want all the direction equal. If you look at this is scale. This scale is 1, 1, 1. So if I hold from the center, drag it, all the x, y, z coordinates are equal. So can you see this? See this? Like this. If you want to make it smaller, you can make it smaller like this. You can drag it like this. Like this. Or if you want to have only x direction, then also just press the end of the arrow like this and drag it like this. Same with the top, bottom like this. Same thing with z. Either you can directly give the values like this. Up to you. So this scale is to make your size of the particular object, to make it bigger or smaller or in that particular coordinate basically. So these four tools are clear. Move hand tool to move the scene. If I move the scene, then my position doesn't change here. Can you see? There is no change in my position of the. Even though I try to move, it's only the scene which moves actually. But if I press this move tool, that particular cube, whatever the object, it will try to move. Even the rotation, it's the same thing to rotate in particular direction. Then it's a scale tool to make it bigger or smaller. 4 tools basically. Am I clear so far?
Yes.
Okay. So the next one is this is a user interface. Rect tool we call this. This is for user interface. So when we are trying to design the user interfaces, I'll come back here again. Okay. So for the time being, these 4 tools are very important for the basic start. So the next one is, I'll also come back to this later. So the next one is okay, you're done with your design. So this is how you design it. This is where you design it. And you want to see the game output. So if I press play button, click on play. This is how we need to do this. Click on play. This is how the output will be there. In output window, you can't change anything. This is the output window. But in the scene window, even to whenever you're trying to play, you can still design and you can change the values. Suppose I want to see this. So I'll make it 2 screens like this. I'll just So now can you see this? The top one is a scene window. The down one is a game window. This is the output window. This is a build window. So only difference is. So now if I try to move the cube, see this. I can move the cube in the scene window. That simultaneously I can see in the game window also. Even though my play button is on, that means my code is running. Even though my code is running, still I can edit the changes in the scene window. You can see the output in the game window. But these values, yeah, let me, once I complete, I'll take your question. So, but one thing we need to keep in mind is these values won't change. Won't save. So whenever there is in the play button, if you try to change my cube position now, I'll try to change my cube position somewhere here, like this, somewhere here. I'll put it like this. So now the value of the position of the cube is 10.71, 3.89, 18.03. But whenever I stop, again, the values of the last saved one, it will go back to that place, basically. See this. It goes back to the same position where the earlier one. But when it's in the off mode, just put the values, whatever you like, it will be automatically saved. Or Control S. So you can edit the changes, you can edit that and see the changes, but you can't save the changes in the play mode. That's what it. Yeah, yes, ma'am. Go ahead.
Sir, how did you get the two windows?
No, this is just a layout.
No, sir, output window and separately, how did you get?
No, these are draggable. You can drag it anywhere you want to put it, like this.
So when we tried, we got full blank, so like black screen.
Okay, did you see there is a man?
Closed.
No. So no. Can you see in the sample scene there is a main camera?
Oh yes, sir. It's there.
Is it there? It's there.
Yes, sir. Yes, sir. It's
If
there.
it's there, then your output should come. If you don't have this, or
Okay.
if it's disabled like this, then it will come like this. This is how you're getting.
No, sir. Actually, completely got blank and application got closed. I mean the everything. We again launched it.
Okay, maybe it's it got frozen. Maybe.
So how do you
Maybe-
disable that main camera and enable it?
No, I see. This is the enable and disable button. This is not regarding to the main camera. I'll come back to that later. I was just showing this is a scene game window where we design this is a game window, we see output. So if you want to see simultaneously, just drag it and drop it somewhere the other side. So I can put it like this somewhere, wherever I feel like. Then you can see generally it will be like this. Generally it will be like this. So you change here, you need to see the output here. But if you drag it and put it somewhere wherever next to each other, then obviously you can see both in a simultaneously, basically. See, now I changed the cube. Sorry, this is the main camera. So this is the cube. So this is the cube I changed here. I can see in the game window. See the next to the game window.
Sir, how we can see outputs on game window? We are changing in this scene window, but we are not able to get on the output screen, sir. So what we have to do?
No. See, two things. One is a play mode. Another one is a off mode. Okay. Right now,
Yes,
can
sir.
you see this? This is in off mode now. I didn't.
Yes, sir.
I'm not.
In off mode, yeah, in
Not
off
in the
mode,
play
we
mode.
are,
So
okay.
whenever I in the play mode, so I click on the play mode, my button will change to blue color like this.
Okay.
Now it
Then
turned to blue.
after that, we have to change the position of this cube, sir.
No. That's what I'm saying. See, listen to me carefully here. See, what I'm trying to say is, if suppose there is some designing work you are doing, okay, you don't know these positions where exactly all this, so you design like this, you change here how it looks here, if I put my cube here how it looks, all these things you change, right? You change the position, that you change that, you are creating the environment. So your models, 3D models, graphic content will be like this, you keep on changing like this. So suppose now if you just off the play mode, what will happen is whatever you change here, whatever the new values is not stored, it will get back to the last original save mode, save position. That's what I'm saying.
Okay, sir.
So now if I off, see this, I'm back to the old position.
Okay.
But if I do change in off mode. Suppose I change my position in the off mode, it's saved now. If I play, come back, it will be the same position. See that.
Okay.
If I come back off, it's the same position. So in the build mode, that is like in the play mode, even though you can change the things, but those things are not saved. You should remember and try to put the values again to save it. That's what I'm saying. You can't save the values. So what will happen is, suppose, see this. Now I try to, this is the error you're gonna get. See, now if you are in the play mode, I try to change the move the cube like this. I try to press Control S. See, it will say that you must exit the play mode to save the scene. That's what it says. Got it? So this is the error you're gonna get. You press Control S.
Sir, but nothing is coming in this game mode, sir. We are changing in the scene mode on the cube. I am changing, but not.
So I'll tell you the reason also why you can't see the things in the game mode. I'll come back to that later. Why? Because so you can see the main camera here.
Yeah, we can see. Yeah, I can see.
Yeah. So what happens is here. So the camera is your eyes basically. You are the player. You see, without eyes, can we see?
No.
We can't see, right? The same thing here also. See, here is the camera. We can see, we generally say main camera. So if I disable it, see what will happen. This is, it's gonna be. So without eyes, it's completely, there is no game, or you can't even build anything like this. See this. You can't do, even though it's built, the play mode is on, it will say like this. Because you should have a camera to show something. We need to have eyes to see something, right?
Yes.
The same thing, same concept here also. We need to have a main camera to show something in the game. So now switch on that camera. So why you can't see is, so come back to the scene window, come back to your scene window and press on the main camera, press Alt and left click mouse button and try to see this like this. If your camera is in the view of the camera, like the area where, see, if you can see this like thin lines, you can see.
Yeah.
So suppose what happens if I move my cube back of my camera, see like this, I'll put my camera in the back position. Can you see?
No.
This is not in the area where I can see, right? So that's why you can't see it. That's only the reason.
Okay.
So what you should do, either you should make your camera move backward like this, or make sure you move your cube before the camera like this. Like this. Now you can see that. See that the camera play.
Okay.
That's the reason you are not able to see that.
Yeah.
Okay.
Yeah. Thank you.
Again, I'll come back to this again. The same thing. I'm going to come back actually. So after this session, what we're going to build a small human structure based on the objects we have. Okay. Then you really understand what exactly how things work. Okay. So this is a play mode. So this is a play button and a stop button. It's the same button. This is a play button, and to stop the game, this is the same button you need to click it. This is a pause button. When you are in the play mode, if you pause the game, you want to pause the game, or you need to click this button. Suppose you want to see frame by frame. So this is the next frame. This is how you need to. So I'll try to show when we are trying to play some games, then I'll try to show how frame by frame we can move. Okay, so this is a scene window to design or build the scene. Game window is the output window where we can see the output basically.
Yeah, excuse me, sir. One more doubt is there. We are not. I am not able to see camera as well as cube at the same time, sir. Either I can see camera or I can see cube, sir.
No, there will be, because all you need to is zoom in or zoom out. That's it. See, if its camera is like this, the small camera shape, cube is like this.
Then how I
So
can
if you so that's what I'm going to say this. See, make sure your thumb of rule is where first double click you on your main camera. It will directly
okay,
take you to the main camera position. So if
okay,
you click
double
on
click.
this, if you click on this position, see this, the position is minus 1.56 0.5 at minus 11. So that means it's towards the left and at the height of 6 and at the back of minus 11.
Okay,
If I take my cube, see this. If I press double click on the cube, see my cube position. Same again, minus 1 at the left at height of 1.9 and at forward at 2.4. So now what you do is generally what we do is, so I make one thing constant. See, either you want your camera to be constant or you want to make your object constant. It's up to you. Okay. So now what I do is generally I keep my position of the camera at 0, 1 and the height. Generally the height of a human being, or you can keep it 2. It's up to you. Generally the height of a human being is 1.8 on average. So 1.6 to 1.8 generally I keep. So it's up to you. 2 also can keep it. It's not, these are not fixed things. I'm just saying that if I want to see at my height the environment, then you should consider in the real time data, like real time what will be my height. So based on that you need to consider. Here one more thing I want to say is, if you this cube, if I just reset, so the cube dimensions are like 1 meter by 1 meter. So this side's 1 meter, this side's 1 meter, this side's 1 meter. So now you want to develop an environment, take cube as a parameter. Based on that dimensions, based on the height of the cube, or based on the cube dimensions, you need to build the environment. Suppose I want to, my character human being should be 1.8. So what I do is generally I go to, I'll take a capsule like this. Okay, what will be my human height is 1.8. Suppose think as a 1.8. So let's take, so now cube is somewhere here at 0, 0, 0. So capsule is also at 0 minus 1.27. So what I do is, so I need to make sure it's 0 first thing, all zeros. So I am at 1.6 height. So cube is 1. See, the position of the scale of the cube is 1, like this. The scale is 1. This also scale is also 1. See this. Now I change little bit like this to 0.5, something like this. Now it's at the head like this. See this. Right, bring it the top, or you can directly put like 1.5 height, 1.6 or 1.5. It's up to you. I'll come back to this also again, but I was just explaining how we need to change the positions, make one thing as a constant, and based on that how to design the environment. So cube is 1 meter by 1 meter. So based on your cube dimensions, always measure, put your cube next to it and try to develop the environment. Okay. So next thing is, so next in the top navigation model, you have this collab. Collab means if you have a team, like, or if you're a single player, you have a multiple hardwares, one at home, one at office, one at some other place, then you can use this collaboration tool. Or if you are like team of a you have a team, then all the team members can collab this. Basically you can use this collaboration like a GitHub, you can say this. So you all can collaborate and you can work on a single project on a different locations or on a different machines. So this is a cloud. Unity also have their own cloud services. So this is a bit expensive. So mostly we don't prefer using the Unity. We go for private, like expensive, like Amazon, Google Cloud, all these services are less expensive. So even you can integrate your Google Cloud, all this into the Unity. It's up to you. So here are your account details and all the stuff. So layers, I'll come when we are in the game. Okay. So this is a layout basically. These are the different layouts available in the Unity.
Sir, still
yeah.
camera and cube both are not coming, sir. I am facing problems, sir.
Can you share your screen?
Yeah.
Yeah.
Sir, we don't have a now that is here. Listen. Yeah, sir. Is it visible, sir?
No, I can't see.
Now, sir.
Yeah, now it's stopped. Yeah. So now if you look at your cube, so see this cube, make sure your first thing is make sure cube 0, 0, 0, 0. Put 0, 0.
So cube I am selecting, sir, and I'm making it 0, 0, 0.
See the value. Yeah. See, even you change the scale also, scale to minus. So there is no minus scale, right? See, you have your scale starts from your body. If you are present in today's physical world, that means it should start from 0 to greater than that. If it's minus, that means it's not visible. That's what. Yeah,
so
just put it
shall I put
1.
1, 1?
Yeah,
Okay,
1. Put 1, 1, 1, 1.
And did also 1, sir. Yeah.
Yeah. It's up to you. See, it's not like this is not mandatory, but it should
Yeah.
not be less than 0. That's what I'm saying. So double click on the cube. Yeah, double click on the cube.
Yeah.
Let's say now you can see the cube. So go to the main camera.
Yeah. This is
Let's
main
say,
camera.
so see this. So main camera is at what location? So now what you do is press Alt button.
Yeah.
Press Alt button and press your left click mouse button and try to move. Oh yeah, try to move. Yeah, exactly. Move.
Yeah.
Zoom out. Zoom out. Zoom out. Zoom out. Zoom out. No, you don't need to press that. See, I'm just saying zoom out. Just remove. Zoom out so that you can see where exactly the camera location is. That's what I'm saying.
Yeah. So
You don't-
7.
No, I can see the value. I want to show you that symbol, where exactly the symbol. You can remove that Alt and left click mouse.
Yeah, sir. I removed, sir.
Yeah. Now just double click on the main camera.
Yeah.
See
Okay.
that. Now can you see this? So
Yeah,
is
now-
it in the position of the main camera?
No, sir.
Is it in visible position? So that's what I'm saying. Either move your camera towards the cube or cube towards the camera. Got
Okay,
it?
sir. Yes, sir. So what value I should choose, sir, initially?
So it's up to you. It's up to you. There's nothing like a standard thing. See, it's all on your this thing. So now you know the position. See, it is at 9. See now. See, that's what I said. Don't do it from the center. That's where the confusion starts. If you do it from the center, these all position values are going to change.
Okay.
But if you do it from the edge of the arrow, no. Go to the main camera.
Yeah.
Go to the main camera.
Yeah, main camera. Yes, sir. Yeah, this one, sir. I have to say.
Yeah. So edge of the camera. Yeah, hold there. Then this will be clear. See, this is only the Z with the values which are going to change. See this.
Yes.
So that's what I'm saying. So now based on this, you can calculate. Okay, if my camera is at 9 and just height and this forward looking, then where should my cube should be? See, suppose I'm in the rotation of this side and in this angle I'm trying to see, then where should it be? It should be opposite to in front of me, right? The object
Yes.
should be in front of me, then only I can see. If I'm at the back, if some object is at the back, can I see? No. The same thing here also.
Okay. So what
So,
I should do, sir, here?
so what you should do is just take your left arrow.
Left arrow means, sir, this one.
No. Red,
Yeah,
red
this.
is for left and right, and blue is for forward and backward, and green is for top to bottom.
Okay, so orange I have to
Yeah.
select, sir.
That is red, not orange, actually.
Oh, yeah.
Yeah.
Red one, sir.
Right. Yeah. Take the red one.
So, sir, I have to drag,
Yeah.
sir.
Yeah. Obviously. Yeah. Yeah. Okay. Just put it. Don't drag too much. See this. You are 14 meters away from the object.
Okay, so what
So
value should
first thing, go to your cube.
Yeah.
Go to your cube.
Yes. Yes, sir.
Make sure your cube is at 0, 0, 0, right?
Yeah, 0,
So,
0, 0.
go to your main camera.
Yeah.
Put everything in the top 0, 0, 0. Only the top, only the position 0, 0.
Yeah.
Yeah. So now put the Y position 1.
X position 1.
No, Y.
Y.
Yeah, Y position 1.
Yes.
And the forward and backward to make it -2 or -3.
Forward means, sir, this X one, sir.
No. Forward backward is Z. That
Z.
means backward to -3. So you're
Yeah.
moving by
So
3 steps back.
minus
-3.
what? -3.
3.
Yes, sir.
Can you see
Yes,
the
sir.
cube now? See, in the game you can see the cube. See here in the game window.
Yeah, in the game.
The down.
Yeah. Now it's visible, sir.
Yeah. If you move a little bit more, you can see the full. Make it -4, -4 or
So, sir,
-5.
our object should be in between this blue
Yeah,
and red.
in that field of view only it should be, actually. Then only it is visible. It's the same thing like our field of view. See, if we are standing in particular location, we can only see from in that field of view only, right? We can't see the back or we can't see, right? Same thing here also. In that
So
field of view only.
you are talking about, sir, XZ coordinate, na, sir? We should keep our object in between XZ coordinate.
No.
Because
Try. Okay, just a moment. Hey, for the rest, there's a short break after from 11:30 to 11:45. You can take a quick break and you can come back. Yeah. So what I'm trying to say is always compare yourself with physical in nature. What in physical in nature, if we are standing somewhere, suppose take an example, you are standing in your home. That means it has some position.
Yeah, Y value, sir.
Not like Y only. There is a X, there is a Y, there is a Z, right?
Yeah, three
So
values.
For always any object, you have
Yes.
all these 3 values anywhere in
Yes.
this space.
Yes.
Same thing. It also have the rotation.
Yes, sir.
That's what this is the same idea. So basically, you are standing somewhere in your house. If you want to see the cube, how do you see the cube? Okay, I'm standing at 0, 0, 0 of position of my home. I'm in
Yes.
the home. So if I want to see something, it should be before my eyes, before me, right?
Yes,
Before
sir.
the person.
Yes.
So what would be that position? It should be always in the forward position. Like that means like what? That means it should be 0 greater than 0 in the Z, right?
Yes.
And the
Yes.
height. If you have some height,
Yes.
then you can see these things like how you see in normal life. You are like you are on the earth to some position at the height, right? Maybe if you consider Earth as a 0, your height is at 1.5 meters. So it's a 1.5 meters, and you're seeing in the forward direction. In the forward direction means
Yes.
you're seeing in the Z direction. So in the Z direction, that means what? it should be, the object should be in front of you. In front of you means it should be in the positive, like in the plus Z something. Then only you can see the value. If it is minus Z, obviously you can't see because it is back of you. You can't see it, right? Unless you turn your body. That means on y-axis, if you turn back, you can see the cube.
Okay, so camera position we are keeping in a minus Z value minus,
one thing
so that we can see the object.
Told you is either you can move the object before me, or I go towards the object, near to the object, and try to move. That's what it is. Yeah. If you think object is at 0, 0, then I should move a little back so that I can see, right?
Yeah. Yes, sir. I got it, sir.
That's a logic here.
Yeah. Thank you so much, sir.
No problem. So the rest you can take a quick break and come back in 10 minutes. So if you have any questions regarding installation or anything regarding this, you can put a question, or you can ask now.